Hi everyone, this is your math guru. In this video, I'm going to discuss the hyperbola. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. Starting with the equation of the hyperbola, the standard equation of the hyperbola is y is equal to a over x. That's the basic equation when the graph hasn't been shifted left, right, up or down. The value of your a will determine the shape of the graph, and also the value of your a will determine the vertical stretch. That is, your a is a vertical stretch, which tells you how close to the axis the arm of the hyperbola is. So for example, if the value of your a is positive, that is, if a is greater than 0, your graph is going to be located in the first and the third quadrant as shown. However, if the value of a is negative, that is, if a is less than 0, then your graph is going to be located in the second and the fourth quadrant as shown. However, if your graph hasn't shifted up or down, left or right, then the equation of your parabola, the standard equation, will be y equals a over x minus p plus q, where your q is your vertical shift. That is, if the value of your q is positive, then it has shifted up, and if the value of your q is negative, then it has shifted down. Also, the value of your p determines if your graph has shifted left or right or horizontal shift, such that if the value is positive, it has shifted left, and if it's negative, it has shifted right. Let's go ahead to asymptote. Your hyperbola has two asymptotes, that is a straight line that continually approaches a given curve but does not meet the curve. The first asymptote of your hyperbola is your horizontal asymptote, and the equation is your y equals to the value of your q. In order to find your vertical asymptote, the equation is your x is equal to your negative p. Let's go ahead and look at an example. In this example, I'm going to show you how to plot the graph of a hyperbola. We have f of x equals 2 over x plus 3 minus 1. To start with, we need to determine the shape of the graph. And remember, we said the shape of the graph is determined by the value of your a. Your a in this case is 2. We have a equals to 2. And note that 2 is positive, so therefore a is greater than 0. What that means is your graph is going to be in the first and the third quadrant. The second step is to determine the equation of our asymptotes. The horizontal asymptotes, we have that as y equals to q. And if you look at the equation, the value of q is minus 1 as shown. So therefore, our y is equal to minus 1. To find the vertical asymptotes, we have that as x equals minus p. If we go back to the equation, we have our p to be plus 3. So therefore, the vertical asymptote x is equal to minus 3. The third step is to find our intercept. And to do that, we start with a y-intercept. The value of x is equal to 0. So going back to our function, we have y is equal to wherever we find x, we replace it with 0. So we have that as y equals to 2 over 0 plus 3 minus 1. That will be 2 over 3 minus 1. So for our y-intercept, the value of y is equal to minus 1 over 3. We're going to do the same for our x-intercept. So for x-intercept, the value of y is equal to 0. So substituting y equals to 0 in our equation, we have 0 equals 2 over x plus 3 minus 1. If we simplify, we have 1 equals, take 1 minus 1 to the other side, 2 over x plus 3. Therefore, we have x plus 3 is equal to 2. Therefore, the value of our x will be minus 1. Thus, so far, we've been able to get the shape of our graph. We've been able to find our horizontal asymptotes, that's y equals to minus 1. Our vertical asymptotes, x equals to minus 1. Our y-intercept, we have x equals to 0, y equals to minus 1 over 3. And our x-intercept, we have y equals to 0, x equals to minus 1. The next step is to find the axis of symmetry. Before I show you how to find the axis of symmetry, I'm going to start by drawing the graph shown, and then in the next step, I'm going to show you how to find or draw the axis of symmetry. Starting with the value of a, I know my a is greater than 0, a is 2, so my diagram or my graph is going to be in the first and third quadrant. The next step is to plot my asymptotes. The first one, I have my horizontal asymptotes, y equals to minus 1. Okay. So drawing that, I have y equals to minus 1. I have that here. Then I have my vertical asymptote, x equals to minus 3. I have that as shown, x equals to minus 3. It's supposed to be a dotted line. I'm going to correct that. Note that my graph is not drawn to scale. This is a rough sketch. Note that you must tag your graph appropriately, where the intercept will be my minus 3, minus 1. The next step are my intercepts. I have when x is 0, the value of y is minus 1 over 3. That will be about here. And the next intercept, when x is minus 1, the value of y is 0. That's for my x-intercept. I have that at this point, such that if I draw my graph, note that the graph goes through my intercept, and then I have a mirror image. As shown, you may decide to pick a couple of points. For example, if the value of my x is minus 4, then my y will be minus 3, which is somewhere around this point. In the next step, I'm going to show you how to find the axis of symmetry using the same graph. Note that the hyperbola has two axes of symmetry, and they intersect at the same place the asymptotes intersect. You have the positive and the negative axis of symmetry. So you have one in that direction, and you have the other one in this direction. One has a negative gradient and the other one has a positive gradient as shown. Using the equation of a straight line, the one that has the positive gradient is, you have this as y equals positive x plus c, and the other one have a negative gradient, and the equation is y equals minus x plus c. Recall that from our equation, y equals 2 over x plus 3 minus 1, that's the equation of the hyperbola, we're able to find the asymptotes, which is, we have that as minus p and q. And we got that as, our p is plus 3, so minus p is minus 3. And we have a q as minus 1, which is the intercept. Therefore, to find the equation of the axis of symmetry, we are going to substitute the value minus 3 minus 1 into the two equation given. So we have substitute minus 3 and minus 1 into, we start with the positive axis, which is the one that has a positive gradient, y equals to plus x plus c. Here we have a y to be minus 1 and our x minus 3 plus c. Therefore our c equals, we take minus 3 to the other side, it becomes a positive. So that's 3 minus 1, our c will be 2. We're going to do the same for the negative gradient line. So we have that as y is equal to minus x plus c. Substituting minus 3 minus 1, we have minus 1 equals minus, I'm going to put this in a bracket, minus 3 plus c minus 1 equals to 3 plus c, minus times minus, that's positive. Therefore, our c is equal to minus 3 minus 1, and that will be minus 4. So what that means is, for our positive axis of symmetry, we have y is equal to x plus c, which is 2 in this case. And for our negative axis of symmetry, we have that as y equals minus x minus 4. So we have a two equation of axis of symmetry. Thanks for watching. Bye.